This is the 40-second LeetCode challenge, and it is called Trapping Rainwater. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So we have the height array here, and we can see on the graph each number represents a height, and the blue ones is the water trapped. So you can see here, if we have 1 and 2, 1, 0, 2, it can trap one block here, as this one is less than this one, and then the math is the difference between this block and the smallest one on the right, left or right. So 0, 1, this difference is 1. Then we have another example here, so 2, 1, 2. So 2 is the smallest, well they're both 2, but then the actual container is 1 high, so 2 minus 1, it can hold 1. Then we can look here, so 2, 1, 0, 1, 3. So the container is 2, 3, so 2. So I've got 1 here, so 2 minus 1 is this, 0, 2 minus 0, 2, and 1 again, 2 minus 1, 1. Okay, so let's get started. So, how do we go about doing this? We need to keep track, when we're going through these, need to keep track of, actually, let's see first what constraints are. Well, first things first, let's do if height.length is less than 3, return 0, because you need, the container needs to be 3, like 1, 2, then in the middle 3. So have that. So we need to figure out for each height, we need to look at if there's one to the left of it which is higher, and if there's one to the right of it which is higher. If that's true, then figure out which one is the smaller one, and then we do the math for this one to this one. So I guess what we can do, create an array for left and right. We go from the left, we go, so we're keeping track of which one on the left is the greatest or the biggest. So we go, okay, what size is this? If the one to the left of it is greater, then we set that to that. Otherwise, set it to the current value. And then we go here. Okay, is this one greater than this? No? Okay, do that. If this one is greater than this, yes, so we then do that. I think that's how to do it. So we'll set up int array left, yep, just like that. And then we'll do right. So we'll start off with the for loop, and we'll just go over everything in the height. So this would be left of I, and how do we want to do this? So the height that's over here on the very first one, this can't contain any water because it's got nothing to the left of it. So we'll start off with left 0 equals 0, and we'll start off with 1. So the numbers that we're keeping track of for each index is the value of the one to the left, what that height is. So because there's nothing to the left, that's 0. And actually no, we're not going to do it like that. We will put height 0 in here, and what we'll do is math.max height I and left I minus 1. So then when we get to the end, we'll have, let's say, over here, the number in left will be 1. So then we know we can then do left minus this. Okay, there we go. And no need to go to the very end, so we'll just do -1 there. And it will be the same thing for right. I'll just put int length equals height length, and we'll just do this. So this will be height length -1 equals height -1. So we'll start off with I minus 2, and this will be greater than 0 minus minus. This will be height I right plus 1, and the one which is greatest. What we then do int total water equals 0. We'll do another for loop for int I equals 1. I is less than length minus 2. So we're skipping the very start and the very end. I++. Then what we want to do is int smallest height equals math.min, and this will be left I, right I, and if height I is less than smallest height, total water plus equals smallest height minus height, then we return total water. Okay, so let's see what this does. Okay, both output is 0, so we will have to manually run through to see what's happening. So we've got height, left, and right. So I'll make 1, 0, then next one is 0. So that should make that 1. Yep, 1. The next one will be 2. Okay, let's skip running all that and go to here. Yep, so we've got 3, 1 here. So 3, 3, 3, 3. And let's go to here. So smallest height is 0. Wait. Oh yeah, that's correct. So carry on from there. So now smallest height is still 0. Okay, I decided to take a quick break there because all the neighbours decided to do their gardening at the same time. So we were trying to look at why it was outputting 0. So let's go through here. Smallest height 0, that's expected. This one, this shouldn't be 0, I don't think. Well, let's do that and this. Try to get a better look at what's going on. So we're currently I0. Okay, so on this one, then left. This looks like it might actually just be. Do these just have the same value? So it doesn't look right at all. Because this one should be 1. Okay, we'll go back to the top here. Okay, so let's put some watch values here. So height I, left I minus 1, then left I. So I did put 1 in there, and we go through. So height I is 0. This should then make that 1. Oh, okay, I see the mistake. Right here. This should be right. Hopefully that was the only mistake that I made. And okay, so this one worked, but then this one didn't. We will go to that one. So skip the first one, go to this one here, and we will first skip down to here. Okay, let's look at the local. So I've got the heights. Okay. No, that looked correct. All of these should all be 5. But this one should be. No, that's fine. Yep, 5, 5, 5, 5. That's all good. This should be all 4s, which it is. So what's smallest height should be 4 for all of them when we do that. And height I is 2. Okay, I think what I was actually after is less than or equal to 2. That might have been the problem. There we go. Okay, so we'll copy this, put it into LeetCode, and run on the test ones. Both of these correct, and let's submit, and hopefully it's all good. And it is all good. So that is the 40-second LeetCode challenge called Trapping Rainwater. If you like this video, make sure to like and subscribe.